This is Brandon Tran, and this is my FRQ test corrections. So starting with part A, I gave myself here a 1 out of 2 because I earned this first point right here for using the right equation. As you can see here and here, it's the correct equation that they want you to use. But I didn't earn the second point because at the very end I got the wrong answer because accidentally right here, from this equation right here to the next to t, I I divided wrong, and instead of putting x over v0, I put v0 over x, and it's just like a small simple mistake that I made. I'm not sure why I did that, but that's the reason why I got that question wrong. So, but it should be x. Well, uh, yeah, so it should be x equal to v0t, and then I believe there was no vertical acceleration, so this canceled out, and then that means t should equal x over v0, and then when you plug this in for t into y, you would get y is equal to 1 over 2a y x over v0 squared. Then that should be the answer, yes, right here. And then yes, so ay is equal to g, because that's the vertical acceleration, and which is positive, so it stays positive instead of negative. And that's why I got 1 out of 2 for that one. And this next one, I gave myself a 3 out of 5. Because yeah, see, because I got this point for listing the appropriate equipment. As you can see right here, I actually said ruler instead of meter stick. And then, but here I said stand, launcher, etc. Then, for plausible practical way, and yeah, as you can see, I put right here, launch and time the ball when it hits the carbon paper, and then measure the distance, and then here, yep, measuring the x, which is right here, how far the ball was launched, based on the distance of the carbon mark. And then the y, which is right here, use the ruler and adjust. Here, use the ruler and adjust. But I didn't do this last part. I didn't add a part that says do multiple trials to reduce uncertainty. So what it should be is that you could just add an extra step, which would be to reduce uncertainty, repeat steps 1 to 4 at um 3 different heights. Heights with at least 5 trials each. And this last step would reduce the uncertainty of the like the stand or the launch. And then this part right here, I accidentally put T, but T doesn't really play a role here, so this should not be here. But this is right. This is the vertical distance, which is y, then the horizontal distance, which is x. Then I didn't need to put these. All I needed was meter stick. Then the next part, did I miss a part? Yes, I did miss a part. Whoopsies. Okay, and then right here for this one, the question was, we've prove I forgot. Right here. Right here. The student wants to use the teacher's data to determine whether the claim that y is proportional to x is true. And to do this, you would just change the x right here into x squared meters squared. So that would change this to 0.25, 1, 2.25, and then 4. And that's just from squaring this. Oh, that is really hard to see. Yeah, and then the next part, which is this. Okay, and I gave this one a 0 because I kind of just ran out of time, so I just put a guess, and this is my best guess, and it's wrong. This is basically saying this is y and this is x, but in reality this should be x squared, not just x. So that would make this graph, and then this graph as well. I ran out of time, so I couldn't do it. But this graph should be x squared meters squared. Oh my god. This should be x squared meters squared. Oh god, that's not better. Okay, yeah. X squared meters squared, sorry. And this will just be y in meters. And then the best way to do is just 1, 0, 1, 2, 3, 4, and then going up could just do 0, 0 0.2, 0 0.4, 0.6, 0 0.8, then 1. And then we just need to plot our points. So it's 0.25, about like 0.2, 0.4. So it's like right here, and then 0.065. So it's like right here. And then next number is 1.25. So it's like about right here. Next is 2.25, so it's 2.5, 2.25 right here. And then 0.5, wait, 6, so it's like right here. And then the final point is at 4, 1, or 4, like right there. So that's plotting these points. And then the final question is does the data in the graph above support the claim that y is proportional to x squared? Okay. And it does, because if we were to graph a line, if we were to graph a line from right here to the very last point, you could see that it kind of like depicts like a straight line. And when like two functions are proportional to each other, that means that they are linear, or that it is linear. Which is you can see that there's this line here, so it's linear. Question was, okay, then that's it. Thank you.